My name's Noah, and I am presenting my group's final project along with Andrew, Mohammed, Ryan, and Jordan. We're excited to present our final design. We propose implementing hydrogen pipelines to achieve a net zero level of GHG emissions by 2050. The focus of this project is to reach a net zero level of GHG emissions by 2050 by retrofitting existing oil and gas pipelines. The key requirements of our design are that it achieves a net zero level of GHG emissions resulting from oil and gas production by 2050, that we determine a sustainable green alternative to our current oil and gas usage, that we meet Canada's current energy expenditure, and that our design is economically feasible.
In transitioning to an alternative fuel source, it's important that we continue to meet current energy consumption levels by Canadians. We found that Canada currently consumes 1,812 petajoules of energy per year, of which 11% comes from oil, gas, and natural gas. We also found that oil and gas emits 0.28 kilograms of carbon dioxide per kilowatt, and Canadian oil consumes $54 per barrel and consumes 1,700 kilowatts of energy.
Here are some measurements of hydrogen relevant to our final design. Hydrogen's energy density is impressively high, sitting at 120 megajoules per kilogram. In terms of electricity, this basically says that hydrogen is able to produce 33.6 kilowatt hours of usable energy per kilogram. Moreover, it would require a gallon of diesel fuel to produce the same amount of power as 1 kilogram of hydrogen in a fuel cell. Another fact is that the production of green hydrogen has zero resulting carbon emissions, and the process of using fuel cells to convert hydrogen to usable energy is a zero carbon process. Green hydrogen currently costs between $2.50 Canadian and $6.80 Canadian per kilogram, but these prices are expected to drop as infrastructure for hydrogen's production is further developed. Lastly, based on our research, we came up with an estimated level of cost of 2.3 to the negative 1 kilograms.
Now, why did we pick hydrogen? Hydrogen is one of the most abundant elements around us as we can get it directly from water. The bonds in hydrogen are high in energy, which makes it great for energy storage. In our design, hydrogen will be mass-produced through electrolysis using a renewable energy source such as wind, solar, or hydro. The process involves using electricity to split water into its components of hydrogen and oxygen, and then capturing that hydrogen to later reuse. Using renewable energies for this process is a must to comply with zero emissions. Now, once the hydrogen is captured, we would need to be able to transport it throughout Canada, and we would use our pre-existing pipelines. Every pipeline would have to be retrofitted with the fiber-reinforced polymer lining to prevent embrittlement and corrosion that hydrogen would have on current pipelines due to their steel construction material. Hydrogen can be stored when it reaches its destination to be converted into energy when needed. Now that we have our hydrogen, we need hydrogen fuel cells to convert that into electricity. Hydrogen fuel cells combine oxygen and hydrogen back together to generate electricity and water, which is completely emission-free. Currently, there are already zero-emission cars that use fuel cells and hydrogen to run, which is absolutely amazing to see. We hope that we'd be able to have the Canadian government give incentives to companies and its citizens to change and invest in hydrogen and energy in its individual products.
Our design starts with the conversion of oil processing facilities in northern Alberta into facilities built to produce hydrogen using electrolysis. Lake Athabasca will be used as the water source due to its location of being close to existing oil facilities, and it's a massive body of water. Then the hydrogen is pressurized and transported through the retrofitted Trans Mountain, Keystone, and TransCanada pipelines to be sold to buyers in Canada, United States, and the rest of the world. In Canada, the hydrogen will be utilized in areas that are not currently using green energy, such as Calgary. Calgary gets a large majority of its energy from the burning of natural gas. These facilities will be converted into large hydrogen fuel cell centers to then harness electricity from hydrogen instead of natural gas. We recommend giving corporations and individuals tax incentives for companies that invest and produce in fuel cell vehicles and power equipment, and as well to individuals who choose to purchase these hydrogen-driven machines.
We think that hydrogen is a very promising response to our user requirements. To realize a level of net zero GHG emissions, hydrogen produces no emissions at point of use, and the production of hydrogen through electrolysis produces no emissions due to all energy requirements being met through green alternatives such as hydro. Hydrogen is very efficient as well, with an energy density of 120 megajoules per kilogram. And with a significant supply of water from Lake Athabasca, there will not be an issue of water supply. In terms of economic impact, there will be an initial investment to convert oil and gas production facilities over to the hydrolysis of water. Hydrogen production will cost more than oil production initially at a cost of $120 per barrel of hydrogen compared to $54 per barrel of oil, but we see this cost dropping significantly as hydrogen is produced at a larger scale. We look forward to continuing working with the Canadian government.